viewers, in this session we will discuss about sulfate attack, acid attack and chloride attack. These three attacks which is very important to the durability of the concrete mass. We will start from the sulfate attack. The sulfate of the calcium, sodium, potassium and the magnesium are the present in the soil or groundwater, and agricultural soils and water contains the aluminate sulfate from the use of the fertilizers from the sewage and the industrial influence, and water used in the concrete cooling tower can be the potential source of the sulfate attack. Solid salts do not attack concrete, but the present in solution they can react with the hardened cement paste. In hardened concrete, the sulfate react with free calcium hydroxide to form gypsum calcium sulfate. Similarly, sulfates react with the calcium aluminate hydrate to form calcium chloroaluminate to the volume of which is approximately 1.17 times of the volume of the original aluminates. The gypsum and the calcium sulfoaluminate have a considerable greater volume than compared they replace, so that the reaction with the sulfate lead to expand and disruption of the concrete. Of all sulfates, magnesium sulfates causes the maximum damage to concrete, which increase the strength of the solution. The rate of the sulfate attack increases. When the concrete is made with the water cement ratio, the concrete can withstand the action of magnesium sulfate for 2 to 3 years. The sulfate attacks is greatly accelerated if alternate wetting or drying, which normally take place in the marine structure. So this is all about the sulfate attack of the concrete. Now let us discuss about method for controlling sulfate attack. First one is use of sulfate resisting cement. Second one is addition of pozzolana. Third one is quality of concrete. It should be good in quality. Fourth one is by using the air entrainment. Fifth one is use of high alumina cement. And sixth one is lining of polyethylene sheet. With these methods, you can control the sulfate attack of concrete. Now let us discuss about acid attack. You can see in the photo on your screen, the concrete is used in the storage of many kind of the liquid, some of the harmful to the concrete mass. And in the industrial plant, the concrete floors come into contact with the different kind of the acids and which damage the floor. In dam condition, the SO2 and CO2 means sulfur dioxide and carbon dioxide affect the concrete by dissolving and removing part of the set concrete, and this form attack occurs in chimney. Acid attack is encountered in under the industrial concrete is also attacked by the water containing free carbon dioxide. And you can see on your screen the photos regarding the acid attack. The sewerage water also slowly causes deterioration of the concrete, and in practice the acid attack occurs the values of pH below 6.5, but the acid attack is severe when the pH value below 5.5. At the value below 4.5, the attack is very severe. Under the acid attack, cement compounds very eventually break down and leached away. If the acids and salts are able to reach the reinforcement steel through the crack or porosity of concrete, the corrosion of the reinforcement take place in your existing site. So keep it in mind this important point in the RCC elements. So this is all about the acid attack. Now let us discuss about chloride attack. In chloride content, the chlorides can enter into concrete during concreting or during service life period. And during the concentration, the chloride can enter via the ingredients like aggregates and gauging water and the admixtures. In service, the condition the chlorides enters into the concrete mass by the sea water, de-icing and other salts. The chloride ions attack the gamma iron oxide film leading to the corrosion. The rate of the corrosion depends upon the chloride ion concentration and chloride levels of about 1% by the weight of cement are high enough to accelerate the corrosion of concrete. And for the reinforcement concrete, the chloride of aggregate should not exceed 0.05 percentage by the mass of total aggregate, and for the pre-stressed concrete it should not exceed 0.01 percentage. And as per the Indian Standard 456/2000, chloride content of mixing water should not exceed the 1000 milligram per liter for RCC. So this is all about the chloride attack. If we talk about effect of de-icing, the salts normally used for sodium chloride and calcium chloride and their repeated application with the freezing or drying result in the surface scaling of concrete, and sometimes the area is used to remove the ice and is less deleterious and less effective in removing ice. When the de-icing agent are applied to the concrete of few weeks age, the damage would be severe. To protect such concrete, boiled the linseed oil and diluted in the equal part with the kerosene or spirit are applied to the surface of the concrete, which must be dry into the two coat. The layer of oil slows down the penetration of dacier solution. The use of this solution also enhances the corrosion of steel, and the and this solution melts the snow or ice, which often the produced by the adjustment ice. As more ice melts, the melts water become the diluted until its freezing point the rises to the near the freezing point of water, and the freezing take place the increase the number of the cycle of the freezing and thawing and promote the corrosion of steel. So this is the effect from the de-icing effect. So let us see photos regarded to sulphate attack, acid attack and chloride attack. You can see on your screen this photo shows that the concrete attacked by sulphate. You can see in the photos, these photos regarded to the sulphate attack. And in the next slide, you can see these are the concrete mass which affected by the sulphate attack. And in the last photo, you can see swelling due to the sulphate attack. This is the pier attacked by sulphate attack, and these cracks due to the sulphate attack. Next one is acid attack. Due to the different type of the industrial acid, and you can see on your screen the concrete affected by the acid in the first photo. This is in the second photo. You can see the transformation after the acid attack of the concrete mass, and here you can see the wall affected by the acid attack. In the next slide, you can see on your screen this block is affected by acid attack, and this surface is damaged by the acid attack. And here these are the cubes which are affected by the acid attack, and the effect, the damage is dependent on the type of the acid. Now let us see photos regarding the chloride attack. Here you can see in this photo RCC is affected by the chloride attack, and this will affect to the reinforcement of the elements by the corrosion. And here you can see this structure which is affected by the chloride attack, and here the reinforcement is caused by the chloride attack. And here in this photo, let us see other photos regarding the chloride attack. Here this bridge is affected by the chloride attack, and this RCC element has been damaged by the chloride attack. And you can see the other photos. Here this surface is affected by the chloride attack, and in the last photo you can see corrosion has happened in the RCC element, in particular reinforcement, and this will affect to the serviceability and the life of the concrete mass. So this all about the acid attack, chloride attack and sulphate attack.